Hello chemists, welcome to lesson 45. Let's just really quickly review something about nuclear reactions. Let's just remember that nuclear reactions relate to changes in the nucleus, either the protons, the neutrons, or both, so electrons can largely be ignored for the most part. Alright, let's also remember that in every nuclear reaction you have a conservation of energy, mass, and charge. So in both nuclear and chemical reactions, mass, energy, and charge must be conserved or kept the same on both sides. Remember, mass number is the top left number, atomic number is the bottom left number. Mass number equals protons plus neutrons, atomic number equals number of protons. And let's remember the number of protons identifies the element. Alright, and this shows that the sum of the masses and charges on both sides must be the same for both sides of a nuclear reaction. Alright, now let's go over how to solve nuclear equations. First of all, what you need to do is, if you have an unknown species in the reaction like X here, or if it's blank, you have to write the mass of X or the unknown species as B on the top left, and you have to write the charge or the atomic number of X as E on the bottom left like this. So you should have X for the unknown with a mass number or top left number of B and an atomic number or bottom left number of E. Now for any unknowns or anything else in the equation, if there's a coefficient in front of any of these species that looks like this, then you have to multiply this coefficient by both the mass on top and the charge on the bottom, which you'll see in a minute. Step 3, you have to then set up equations between the reactants on the left side and the products on the right side so that the charges on the bottom and the masses on the top are equal on both sides, and so that you can solve for them. And in step 4, you have to solve for the unknown mass and charge, and then you have to use table N and O if they're one of the nuclear emission particles, or you have to use the periodic table if it's an element based on the atomic number to identify the unknown element or particle. Okay, and for the most part, the charge will tell you everything. The charge using table N or O will let you identify the nuclear emission, and the charge also serving as the atomic number can also help you find the element on the periodic table that you need to use for the symbol for the unknown element or particle. Okay, so let's do some practice with nuclear equations. And as we go through these, there are some that are blank, and that's because I want you to solve those. Alright, so like these that are blank, I want you to just go through on your own. But don't worry, I'll take you through step by step so we can understand this better. So what you have to do, step 1, is for the unknown species X, make its mass B on top and E on the bottom, right? And then step 2, what we have to do is we have to multiply a coefficient in front of anything by the mass and charge. We don't have any of those, so we don't have to worry about that. Step 3, we have to set up equations between the reactants and the products so that the charges on the bottom and the masses on top are equal. So if we do that, we have the mass on the top left in the reactants is 58, and that's equal to the sum of the masses of the products for Ni and X, which are 58 plus B. So 58 plus B in the products is equal to 58 in the reactants. All right, and then for the charges in the bottom, the charge in the bottom left or the for the reactants is 29 for Cu, and that's equal to the sum of the charges on the bottom left for the products, which is 28 plus E. 28 coming from Ni, E coming from X. And if you solve for these, if you solve for B and E, you get B is equal to 0, so the mass of the unknown particle is 0, and the charge, or E, which is the bottom left number, is positive 1. Now, you have to look on table O for this. Now, if you check on table O, you'll see that the only particle with a bottom charge of positive 1 and a mass of 0 is a positron. So you write 0 plus 1 E or 0 positive 1 beta. So I just put 0 1 positive 1 E, and that's really it. And here, the type of natural transmutation or decay occurring is the positron decay mode, because obviously 0 plus 1 E is a positron. I think you know what I'm doing there. All right, so use that same approach right here. I'm just going to tell you right now, and I gave you this as a hint, is that B is the mass of X and E is the charge of X. So solve for that on your own. All right, if you have a lot of problems with this, just make sure to email me. Now, the next one we have here is 239.94 PU's decays to form 235.92U plus X. So for X, for its mass in the top left, let's just put B. For the charge in the bottom left, let's just put E. All right, so if we solve for these, we get that the mass on the top left for the reactants is equal to 239, and that the sum of the masses on the product side in the top left are 235 from U plus B for the mass of X. All right, so the sum of the mass on the product side, 235 plus B, is equal to the sum of the masses on the reactant side, 239. All right, and if we solve for B, we get that the mass of the unknown particle X should be 4, since B is equal to 4. Now, for the charges, we know that the sum of the charges on the reactant side, which is just 94 for Pu, is equal to the sum of the charges, or the bottom left numbers, on the product side, which is 92 for U plus E for X. So 92 plus E, the sum of the charges on the product side, is equal to the sum of the charges in the reactants, which is 94. And if we solve for E, we get E, or the charge of the unknown particle, X is equal to 2. So what particle has a mass of 4 and a charge of 2? If we check, we'll see that on table O, it is an alpha particle. All right, so we just write 4,2He for the notation here, and we know it's alpha decay mode because we release a particle with a charge of 4, charge of 2 rather, a mass of 4 and a symbol of He. All right, next here we have X plus 0, negative 1e produces 168, ER. So what we have to do again is just make the mass of XB, the charge of XE, and we have to set the sum of the masses, B plus 0 on the reactant side, equal to the sum of the mass on the product side, which is 168. If we solve for B, we get B is equal to 168 for the mass of the unknown, X. Now, we also have to set the sum of the charges on the reactant side, or the bottom left numbers E plus negative 1, equal to the sum of the charges on the product side, which is 68. So E minus 1 is equal to 68. If we add 1 to both sides to isolate E by itself, we get E, or the charge of the unknown particle, is 69. So what has a charge or atomic number 69 and a mass of 168? Well, since it's not listed anywhere here, we have to go to the periodic table. What has a charge or atomic number of 68? If we check here, it's not here, so we got to go down to the lanthanides and actinides. We see that the element here would be, let me see, Tm here. All right, so we have Tm with a charge or atomic number of 69 and a mass number of 168. All right, so that's your unknown particle X. And notice here that we have an electron here on the reactant side, so going back to our last lesson, we know there's electron capture. Okay, next we have 4522 Ti decays to produce 0 positive 1e plus X. So what we have to do here is we have to solve for we have to set the sum of the masses on both sides and the sum of the charges equal on both sides. So the mass of X on the product side here is B, the charge is E. So the sum of the masses on the reactant side, 45 for Ti, must be equal to the sum of the masses on the product side, 0 plus B. If we solve for B, we get that the mass of the unknown particle X is 45, or B is equal to 45. And then we have to also set the sum of the charges equal on both sides. So the sum of the charges on the reactant side, or the bottom left number 22, is equal to the sum of the charges or bottom left numbers on the product side, 1 plus E. If we solve for E, we get E, or the charge of the unknown particle, is 21. So what has a charge or atomic number 21 and a mass of 45? If you check on table O, it's not on there. But if you check the periodic table and look up the atomic number 21, you'll see that that matches up to SC. So X's particle has a mass number of 45, obviously, since that's B. The charge is 21, or the atomic number is 21, and the symbol is obviously SC, because that's 21 is the atomic number for SC. All right, and this is a positron decay mode here, because you notice that a positron is being produced or emitted on the product side. This you can do on your own, and this you can do on your own, but let me go over these two quickly. Again, the mass here of X should be B, the charge should be E. Now you just set the sum of the masses on the reactant side equal to the sum of the mass on the product side. If you do that, the sum of the mass on the reactant side, B, is equal to the sum of the mass on the product side, 27 from Al plus 0 from 1, positive 1e. If you solve for B, or the mass of the unknown particle, is 27. And for E, the sum of the charges on the reactant side, E for X, is equal to the sum of the charges on the product side, 13 from Al plus positive 1 from E. So if you set the sum of the charges on the reactant side equal to the sum of the charges on the product side, you get E is equal to 14. And if you look on table O, there's no such particle with a charge of 14, so you're going to look in the periodic table. What is the charge or atomic number 14? Si. So we know the symbol here is Si, the mass, obviously, or B, is 27, and the charge is 14. All right, so that's your unknown particle X, which is Si 27, with an atomic number charge of 14. And since a positron, or 0 positive 1e, is emitted here on the product side, you know it's positron decay mode. This one I think you can really do on your own. Just make sure you solve for it, set the masses and charges equal to one another, and then you get that X has a charge of 37, a mass of 80, and if you check the charge of 37 or atomic number 27, it's Rb on the periodic table. And since you have an electron here on the reactant side, you know there's electron capture. Do this on your own. All right, so let's do some more advanced problems. All right, so here we have Be9 plus H1 produces He4 and X. You'll learn later that there's actually something called artificial transmutation, because here you don't have one reactant, but rather two reactants reacting to change the element. But we'll talk more about that later. Now, all you have to do is set X's mass equal to B, X's charge equal to E, so you have to set the sum of the masses in the reactant side, 9 plus 1, from B, E, and H equal to the sum of the masses on the product side, 4 from HE plus B from X. And if you solve for B and simplify, you get B is equal to 6. So the mass of the unknown particle X is 6. And then the sum of the charges on the reactant side, 4 plus 1, 4 from BE, 1 from H, is equal to the sum of the charges on the product side, 2 plus E, where 2 is from HE for the charge, and E is the charge of X. And if you simplify and solve for E, you'll get that E is equal to 3. So the charge of the unknown particle is 3. If you check on table O, that's not on table O, so you have to check on the periodic table. What has an atomic number or charge of 3? If you check, that matches up to Li. So the symbol is Li, the mass is 6, the charge is 3. So that is your answer for number for this number. I believe that is number 9. All right. So again, here you have a mass of B, a charge of E for X. Set the sum of the masses on the reactant side, 239 plus 4, equal to the sum of the mass on the product side, B plus 1. And set the sum of the charges on the reactant side, 94 plus 2, equal to the sum of the charges on the product side, E plus 0. If you solve for B, you get B, or the mass of the unknown particle, is 242, and E, or the charge of the unknown particle on the product side, is 96. If you check, it's not on table O, so you got to check the periodic table. What has an atomic number or charge of 96? You'll see that that's Cm. So X is the particle Cm, where you have a mass of 242 and a charge of 96, and the symbol Cm. All right, here it's a little trickier because what you have to do here is you have B and E for X as always. But what you need to do here a little differently is for this neutron here, since it's 1, 0, N with the 4 in front, you actually have to multiply 4 times 1 and 4 times 0. Because remember, whenever you have a coefficient according to our steps, you have to multiply by both the mass and charge. So how you set up this math for the masses is the sum of the mass on the reactant side, 239 plus 18, is equal to the sum of the mass on the product side, which is B plus, since you have a coefficient of 4 in front of here, you have 4 times 1 for the total mass of these 4 neutrons. And the sum of the charges on the reactant side, 98 plus 8, must be equal to the sum of the charges on the product side, which is E from X plus 4 times 0, since you have 4 neutrons instead of 1. So you multiply 4 times 0. And if you solve for B, you get B is equal to 253, or the mass of the unknown particle is 253, and the charge of the unknown particle is 106. And since 106 is a charge that's not shown in table O, check it on the periodic table for atomic number, and you'll see that matches up to Sg. So that's why you have this answer right here, okay? Now, this is going to be a little trickier as well, so I'm just going to break this down for you. Basically, what you do here is you set some of the masses on the reactant side equal to some of the mass on the product side, and same thing for the charge. Some of the charges on the reactant side equal to some of the charges on the product side. Now, this gets a little trickier because now you have X with a charge of B, mass of B and a charge of E, but you have a 4 in front as well. So what you have to do here is whatever B is, you have to multiply it by 4 and make the mass of 4x 4b. And the charge of 4x must be 4 times E, since the coefficient multiplies the charge in the back, giving you 4e for the total charge of 4x. All right? Because all you're doing is multiplying the coefficient in front here by the mass up here and the charge down here. It's just math, basically. Think of it as a coefficient in math. All right? So the sum of the masses on the reactant side are 249 plus 15 is equal to 260 plus 4 times B for the product side. And if you solve for B, B is equal to, 4B is equal to 4. And if you solve for B, B is equal to 1. And then the sum of the charges on the reactant side, 98 plus 7, must be equal to the sum of the charges on the product side, which is 105 plus 4 times E, since it's 4x instead of just x. If you solve for 4e, you get 4e is equal to 0. If you just divide 4 on both sides, you get e is equal to 0. So if you check on table O, the particle with the charge or bottom left number of 0 and a mass or top left number of 1 is just a neutron. So you know x is equal to 1, 0 with the symbol of n that indicates a neutron. This last one, just look over on your own. And these next few, please solve this on your own, look over these two on your own. But I'm just going to go over this one just so you understand how to do this. So you know the mass of x is B and the charge of x is E as always. Now what you have to do with the 1510n and the 70-1e is just multiply the coefficient by the mass and charge for both of these. Alright, so if you do that, you have to, after you do that, you have to set the sum of the masses on both sides equal to each other and the sum of the charges on both sides equal to each other. If you do that, you get the sum of the mass on the reactant side, B plus the coefficient 15 times the mass of 1 here, for the total mass of the reactant side is equal to the sum of the masses on the product side, which is 253 for the total mass of ES plus this coefficient of 7 times the mass of 0 here for 7 E's, or 7 electrons. And if you solve for B, you get B is equal to 238. And here for this other one, you get the sum of the charges on the reactant side is equal to E from X plus for these 15 neutrons, 15 times 0, since you multiply this 15 coefficient by this charge of 0 for this neutron. All right, so E plus 15 times 0 is this is the sum of the charges on the reactant side. And you have to set that equal to the sum of the charges on the peroxide, which is 99 for ES, plus 7 times -1 for these 7 electrons. And if you solve for E, you get E is equal to 92. And what is an atomic number 92? U. So you have 238, 92 U here. Okay?